So in this presentation we have to talk about scattering cross section. For that we should know the meaning of the word scattering. If the incoming particles are approaching a target material, say a scatterer, they may be subjected to some angular deviation. Suppose all the particles are far away from the scatterer, they may not realize any force. If they approach closer to the target, they can be deviated to some extent. Therefore, in the process of scattering, two concepts are majorly concerned. One is momentum transfer and the second one is angular variation. After the scattering process, the path traced by the scattered particles is also a straight line. Therefore, the angle between the initial and final straight line paths is called scattering angle. During the process of scattering, if there is no change in the energy of the target, such scattering is called as elastic scattering. If the energy of the target material is changed, such scattering is called as inelastic scattering. To understand more about the term scattering cross section, we should consider a number of particles crossing unit area normal to the beam in unit time, and among the capital N number of particles, small n be the number of particles scattered into a solid angle in unit time. Now we can say the differential scattering cross section sigma of theta comma pi, which is equal to small n divided by d omega whole divided by capital N. This is the formula for differential scattering cross section. The term cross section means area available for scattering. Here the value of theta is polar angle. Then the meaning of pi is azimuthal angle. First of all, we should know the difference between polar angle and azimuthal angle. For that, see this diagram. Suppose a particle is moving in a two-dimensional plane. The angle theta is sufficient to describe the motion of the particle. Whereas, if the particle is moving in a three-dimensional plane, we need two angles. One is polar angle theta and another one is azimuthal angle pi. Now we have to place a question, what is meant by azimuthal angle? See here, this is XYZ, a three-dimensional plane. The position of the particle is represented by the position vector r, and the position vector r makes an angle theta with this z axis. So this is called as polar angle. The value of polar angle is varying from 0 to pi. That means 0 to 180 degree. Now, draw the projection vector from this origin and keeping this value of r as the length of the projection vector. If you draw the projection vector in the xy plane and the projection vector makes some angle with the x direction, this angle is called as azimuthal angle pi. Then pi varies from 0 to 360 degree. Now you have to coin the term solid angle d omega. The solid angle d omega is equal to surface area divided by r square. Here surface area is the area measured by the portion present in the spherical surface. Say, how do you calculate the surface area is detailed here. See, this is one side and this is another one side. If this radius vector r makes an angle theta and this length is r, then this portion is r into theta. This is one side. Now you have to calculate another one side. This side we should know. See here, if this is pi, then this is d pi. This angle is d pi. If this is r, then this value is r sin theta. So this side is radius vector into angle. That means radius vector is r sin theta, then this angle is d pi. So this side is r sin theta d pi. This is nothing but this side. This is one side r d theta. Then the value of another one side is calculated by this projection. Then the value of this side is r sin theta d pi. Therefore, surface area is equal to this side into this side. That is, r d theta is one side value and another one side value, this side value is r sin theta d pi. So r sin theta d pi into r d theta is the surface area divided by radius r square. This is radius r. So square of the radius r square. So this is the value of solid angle. Now come to our scattering part. Here differential scattering cross section sigma of theta comma pi, which is equal to small n divided by d omega. This is solid angle d omega whole divided by capital N. Here capital N be the number of particles approaching the target, small n be the number of particles scattered into the solid angle d omega. So this is the formula for differential scattering cross section. Now if you want to calculate the total scattering cross section, just we have to integrate this sigma of theta comma pi into d omega for entire solid angle. We have to extend this equation. The solid angle d omega equal to surface area divided by radius square. This is r sin theta d pi r d theta divided by r square. That is equal to sin theta d pi d theta, because r square r into r cancelled out. Then total scattering cross section sigma equal to differential scattering cross section into d omega, entire should be integrated. Already we discussed theta is lying between 0 and pi, and the pi is varying from 0 to 2 pi. Therefore, see this, just I have substituted sigma of theta comma pi d omega equal to sin theta d pi d theta. Now if you integrate d pi, you can get pi and apply the limit. Lower limit is 0, upper limit is 2 pi. So this is 2 pi. Then integral of sigma of theta comma pi sin theta d theta, limit varying from 0 to pi. Now this is called as total scattering cross section. For spherically symmetric potential, sigma is a function of theta only. Sigma is independent of pi. What do you mean by spherically symmetric potential? If the potential is the function of r only, which means that the particle is positioned at a particular distance from the fixed point. So the potential energy is depending upon only the position vector r. That is called as spherically symmetric potential. In the case of spherically symmetric potential, only one angle is sufficient to describe the motion of the particle. That angle is theta. No need for pi. Therefore, sigma of theta comma pi is changed as sigma of theta. Sigma total is equal to 2 pi into limit varying from 0 to pi sigma of theta sin theta d theta is the value of total scattering cross section. Cross section has the dimension of area, hence we can say the area available for scattering is called cross section. The unit of cross section is born. One born is equal to 10 power minus 24 centimeter square or 10 power minus 28 meter square, because to convert centimeter into meter, we have to multiply this with the help of 10 power minus 2. Here centimeter square. So if you want to convert into meter square, we have to multiply by 10 power minus 4. Therefore, 1 barn is equal to 10 power minus 24 centimeter square or 10 power minus 28 meter square. In this way, we have arrived an expression for total scattering cross section.